Okay, Cap. So welcome to the third part of the lecture, of today's lecture, which is the second lecture, and there. Okay, so we talk about approaching the subject, definitional, etymological, how you can approach subject as a trigger for wide-scale disruptions, and how the part you will play, whether it's active, interactive, or just passive appreciation of emerging technologies, right? And one of the main things we had discussed was the law of unintended consequence, right? The causal problem, which means a lot of chemical innovation, for example, CFC, thalidomide, PFAS, all this, you haven't worked out the causal chain all the way, from say, in the case of thalidomide, from preventing morning sickness to causing birth deformity, birth defects, right? So some of this is historical, some of this is still with us. So the reason we have this is because we don't have the capacity, nor the inclination, nor the foresight to anticipate what will happen. Okay, so good things now can become bad things later. That happens a lot, and that's why we have to talk about sufficiency economy philosophy. In particular, the second principle emphasizes the notion of causal nexus, working out, analyzing the causal chain, right? Before you commit yourself to any kind of project or endeavor. Then you have the conceptual problem, that's sort of like good ideas that gets bastardized or gets misinterpreted deliberately or otherwise. Okay, so becomes something very good, like understanding of how economy works, to promoting the kind of economy where everybody's out for himself, and the rich keeps on taking advantage of the poor by accumulation of capital, which is in turn is used to take advantage of the poor and so forth. Right. And also the conflict part, I put conflict, especially in the game theoretic sense, or including in the game theoretic sense. Sometimes what you do that benefit the few can harm the greater community, or private gains and public loss, and that sort of thing. But sometimes it's not deliberate. It's everybody's acting rationally. And a good example, the best example here is the Bayes paradox in terms of traffic. What makes sense for you to do ends up making the whole traffic slow down. And this is where you have this discovery that sometimes if you have more roads, you have worse traffic. And that's not just because people are driving more, same number of cars, right? Same number of cars. There's also the fact that once you build more roads, more people are likely to drive rather than use public transportation. That's also the story. But Bayes paradox here, it's not increased number of travelers. Okay, same number of cars, same destination from A to B, but if you have two streets from A to B, it parallelizes the process. Once you create a link between, it allows individual to shortcut some time from their travel, shortcut their travel time. But once this gets realized, then everybody jumps in and effectively serialize the traffic and makes everybody go slower. Okay, so that's good. So that's the schema that I want to provide you with today, how to approach a subject, right? And the law of unintended bad consequence. So having done that, I'm going to stick this under schema. Okay, I'm going to stick this under schema. Right. Close that. Okay, now let's go to some framework stuff. Today we'll talk about things you need to know. Now for this, I'm going to refer to a separate PowerPoint. You guys remember what I said last class? This class is supposed to spur you to think logically, systematically, and also have a very generalized overview of how things are related to one another. So there's like a big graph organizing concept. So mind map is very good, but occasionally I would use PowerPoint. And PowerPoint, like I told you last class, originally it was good as a marketing tool. You know, when you're trying to pitch a project, you start with slide 1 and say, oh, don't you have this problem? Number 2, oh, see, this is a prevalent problem. A lot of people have this problem. Slide number 3, you know, there's a solution. Number 4, you know, nobody provides better solution than we do. Number 5, if you use us for consultancy or for marketing campaign, you benefit, blah, blah, blah. So we control the narrative because you have a captive audience, right? Slide 1, slide 2, slide 3, slide 4. You can't deviate. You can't go off on tangent. So I think so I have a bit of that because I literally have a narrative to control. So that's good. Class material, things you need to know. Things you need to know. Okay. Right. So let's put this under things you need to know. Okay. So this one because okay, things you need to know. Now, what I mean by things you need to know here is the narrative. Again, I'm linearizing the narrative so that by the end of this, I'm trying to convince you that even if you are not technically inclined or even if you don't like a lot of math, mathematics is going to be behind any kind of analysis, conceptually, computationally. Conceptually means if you have a mathematical way of thinking about things, okay, and this sort of like is echoed in the this syllabus item where you have mathematical thinking, scientific discipline. But if you have mathematical thinking, okay, if you have mathematical, in other words, you think through mathematics, you think with mathematics, you think like a mathematician, okay, it's gonna it's gonna fortify your capacity to analyze much better than people who are not thinking mathematically. And I don't mean doing equations. I mean doing things as you would in mathematics. Okay, so that's things you need to know. Maybe I can put in terms of mathematics, and in the end, that's gonna be how you interpret any subject. Okay, and this is a little bit like a mental exercise. Okay, clear your mind of whatever you think you know in terms of analysis, right? So if you need to know something, what do you need to know? You learn about something, what do you need to know? You're interested in a product, what do you need to know? You're interested in a concept, what do you need to know? You are doing data science, data analytics, bioinformatics, what do you need to know? And this is starting from like empty, nothing, zero. You know nothing, okay? No random variable, no statistics, no distribution, no function, nothing. Okay, start from zero, okay? Okay, let's go. We have 20 steps. Step 1, you can name anything, okay? You can name anything, okay? This, for example, is Pumjai, that's me, okay? You can name this thing as Pumjai. It's the first thing you know, okay? You can name anything, okay? Again, if you know it, the first thing you know is you can name anything. Step 2, everything that you name has attributes, okay? So here, you name this thing as Pumjai. Here, Pumjai has what? Pumjai has name, has citizen ID, has genomes, right? My gene, genetic set, my sex, age, height, weight, nationalities, religion, degree, home address, phone number, email, physical whereabouts, my location right now, heart rate, emotional states, right? Some of this you would notice is permanent or semi-permanent, like citizen ID, right? My genome, well, my genome can change a little bit, but by and large, it's fixed from birth. Age, it changes deterministically. Height, not quite. Phone number, fixed, but can be changed. So, right? Physical whereabouts certainly changes all the time. So everything has attributes. These are called attributes. Okay. Other things of the same class also have attributes. So if Poomjai has age, okay. In other words, these are the attributes. Poomjai, oops, sorry. There's another guy named Paiju, all right? He also has attributes. This is what we mean by a class. Okay. Class refers to set of attributes you use to define member of that class. So everybody that belongs to this class must have some value for age, for whatever. Okay. So now we don't have just one thing. First we have one thing. Okay. First we have one thing that you can name. That thing has attributes. That thing belongs to this class of things that also have attributes. Okay, this is like you coming from an alien civilization. This is how we human beings organize knowledge. Now, attributes are distinguished by measurement. Okay, why am I different from you? Okay, you say, well, I'm one person, you're another person, right? Poomjai is not Paiku, but actually it's by measurement. Well, what is the measurement? How do I know that this is one person? Let's say you come home and you see one person. You married to a twin, identical twin, right? You come home to your wife and you see her, and you just talk to your wife, and she said she's in the office. So you can conclude that this is not your wife. This is actually your twin, the twin sister of your wife. Well, actually, you know, even though they have different names, you have different shared experience and whatnot, the reason you know that this is not your wife is because of the measurement you made. And that measurement is physical whereabouts, right? When you talk to your wife and you confirm that she's at the office, okay, the measurement you make is her physical whereabouts. She's there. And then you have someone that looks just like her, so maybe same height, same age, same weight, same sex, nearly perfectly replicate genome, and you can have everything else the same, maybe live in the same house even, but you took the measurement and this is a different person. Why? Because you take measurement. The physical whereabouts is different. Next, measurements are distinguished by scales. And this is where this becomes something very important, okay? And I put a lot of emphasis, maybe like 10 minutes on this slide alone for my data analytics class. Well, not this slide, but this concept. The idea is that when you take the measurement, they have different kind of scale. And different kind of scale impart different level of information. A nominal scale can only do inequality. Okay, A is the same as B, but not C. An ordinal scale, you can rank things. Okay, you can say A is less than B, right? You can rank. You can rank. Okay, so you can name, you can distinguish. Yeah. So let's say distinguish. Okay, you can distinguish, you can rank. Now, a good example of ordinal scale is a beauty pageant, right? You can say that Miss Universe is more beautiful than runner-up. First runner-up is more beautiful than second runner-up. But what you cannot do is measure the distance between them. Okay, that's where interval scale comes in. You can do subtraction. So all this, okay, this is all concept that lead to how you define your knowledge, but it's all grounded in mathematics. These are the operator that you have to care for. Okay, so nominal scale, you can do equality, inequality. Ordinal scale, you can do less than equal to. greater than or equal to. Interval scale, you can do subtraction, right? So even though you can't say how much more beautiful is Miss Universe to the first runner-up, you can say how much taller the first Miss Universe is from the runner-up, and vice versa. Okay? Same. Now, when you get, but this, you don't have absolute zero, so you can't take the ratio. The ratio would be something that has absolute ratio, like length. Okay? So temperature, for example, you can't say that the room that is 25 degree is twice as warm as the room that is 12.5 degree, because that only works in centigrade, it doesn't work in Fahrenheit and so forth. Okay. Finally, there's a scale that you don't that will become more relevant when you do artificial intelligence, and that's called fuzzy scale. That's sort of like scale that is linked to a concept. So, for example, what do you mean by hungry? Okay, hungry on a scale of 0 to 1. Okay. Good. Okay, so you can measure by scale. Things are missing. Now, this is where it gets more interesting. Attribute measurements are distributed. Well, what I mean by distributed is that not everybody can share every single attribute, right? Kumjai and Paiju can have the same exact height, but at the end of the day, at least we differ by physical whereabouts. So all the elements, if you don't look at the whole row of attributes, you look at just one attribute, and you look at the same attribute for every person, everything from that class, you will see that it is distributed. It's not distributed means cannot just have one value. And that becomes the basis later on for doing analysis. Hence, you study statistical distribution. Right? So that's why at the end of the day, you have to study statistical distribution, probability and statistics, regardless. So notice, right? From here all the way down, I haven't mentioned any subject whatsoever. I don't care if you're interested in art. I don't care if you're interested in health science. I don't care if you're interested in sustainability. I don't care if you're interested in blockchain. I don't care if you're interested in smart cities. These are generic things. Okay. The point is that you only get to know your subject by attributes, and attributes are distributed. Statistical distribution is the tool. Again, we talk about frameworking. It's the tool by which you organize. All I said was that not every person can share same exact value for every attribute. When they differ, what does it mean? I have 100 person, only 2 values, male and female, and only one person is female, everybody is male, or 50-50, or maybe it's not male, female, maybe in the form that you take a survey that's male, female, and unstated, or prefer not to say. So you have 3 classifications, right? So all I said here was that attributes are distributed. Not everything, every individual from the same class can share every measurement. Okay? And when they differ, they create a distribution. That's why you do this histogram, you do this sampling. Sampling means you take the value, histogram and you plot. And we're going to talk about that in the visualization tools. Okay. Then you have concept of random variable probability. I'm not going to go into details here, but you have that in the statistics class, right? Probability mass function, probability density function, cumulative distribution function, random variable, and so forth. So this is why you have to study. I don't care what your interest is. Okay. Now, Next thing, some attributes are constant, some aren't. I mentioned a bit about this already, right? My citizen ID is a constant. My phone number is a constant, but it can be changed. Okay, but it has to be, there has to be some function, there has to be a protocol, there has to be an algorithm, there has to be a method, there has to be a protocol that changes my phone number. Okay, it doesn't, I don't just wake up today and my phone number changes. Okay, can change deliberately with something. Okay, there's something that changes at a constant rate. My age, for example, I get a second older every second. Okay, that's not how I feel, but I get 1 second older every single X second. So this is constant rate. Okay, I'm going to change the word here. Constant rate is deterministic. Okay, now my heart rate, on the other hand, changes stochastically. In other words, you know, right now it is, where am I? Oh, well, right now it is 56 resting heart rate. So it can go up to 130. Let's say I was running or whatever, right? It changes stochastically. Okay. Now this is just changes, right? Not taking into account many things. Okay. Next. Measure attributes are related by definition. By definition, it's not only that I have this. It's not only that I have this, but some of these are related. Okay, some are not, some are independent. Okay. Can be related by definition, not all of them. For example, this is a very clear-cut case. Well, volume is always length times width times height. Okay. By the way, I use this font because this is what mathematical code would look like. So we write that. Okay. Volume this is equal to volume length of this, width of this, height of this. Okay. So this it sounds a bit silly. This is very silly, but this is exactly how you would do functional programming. Okay, you tell the computer this. You tell the computer that how do you do volume? You take height, you take width, and you take depth, let's say, equal to height times width times depth. That's it. And you're done. Okay? And then you say the volume of this block of wood equal to volume, okay, 5 centimeter high, 10 centimeter, 21 centimeters wide, and 200 deep. Okay, that's it. This is how you tell a computer. There's always 2 steps. This is as simple as it gets. This is functional programming. You define the function, then you invoke it. Okay, so this is called define the function, and then you invoke it. Okay, that's it. Now, so this is it. Right? Can be related by definition. What else? Measure attribute can be related by phenomenon. Now, phenomenon meansปรากฏการณ์, things that happen. In this case, well, in a way, this phenomenon is man-made, but certainly, this is what happens. If you put in D, that's amount you deposit. If you put in interest rate and you put in the amount of time, at the end of that time, you get this much money. Okay? So again, it's related by phenomenon that's mathematically described. Okay? Now, often, relationship implies proportional change, right? And this is where you get the first inkling of understanding what a function does. And this takes you back to 5th grade, the notion of proportionality. Okay, the notion of proportionality, okay, right? Every year changes, the height changes, that sort of thing. It's proportional, right? When you were young, you realized this. When you were 5 years old, going to 6 years old, you grew a little bit. When you go to 7 years old, that's 2 years. You give you twice as much room to grow. Maybe you grow twice as much, maybe not. But it's proportional. Then you study linear algebra. This is 5th grade, by the way, guys. This takes you back to 5th grade. Okay, so it's one form of proportionality. It has a constant proportionality. It has a starting point, right? But often, and this is where you begin to realize a limitation, relationship is non-proportional. Okay, so it's non-linear, basically. Okay, it's non-linear. Okay, so you in 1 year you grow 5 centimeters. In 2 years you don't grow 10 centimeters. You grow maybe 8. Okay, it's non-linear. It's non-proportional. Okay, so if it's non-proportional, you can't do this. You can't take the division. You can't take division over 1 year, division over 2 years. So this is year 1 to year 2. This is year 1 to year 3. So what you want to do is instantaneous change, right? Change in Y per changes in X, but not over a long average of 1 year, but maybe instantaneous. That's what you want to do. Okay, so you want to know how it changed, not from 1 year to the next, but from 1 year to the next breath. Okay, so you want instantaneous change. Hence, you study differential calculus. That's why, regardless of using health informatics, sustainability, your rate of change, the rate of change, you're interested in the rate of change. But if you stay in your 5th grade, you can only study phenomena that has a constant linear growth or decline. I will tell you that in life, practically none of that happens. There's no linear change anywhere in the universe. There's only something that approximately linear when you look at very small. Okay, right? So you study differential calculus. Okay. Now, because you have changes, right? From when you're 5th grade to 6th grade to 7th grade, you accumulate the change, but you don't have that constant, but you still want to know what accumulated change is, right? So over a big step of a year, you want to go back to that analysis. Okay, you know instantaneous rate of growth, but you want to know in 2 years' time, in 3 years' time. That's why you have integral calculus, which is the flip side of differential calculus. Okay, so when I say hence you study, that means right now, to know anything anywhere on Earth, you need to know statistical distribution, you need to know differential, you study differential equation, you study integral calculus. Okay, so right now, the reason I want you to think mathematically is that, and this is my claim, okay, this is my claim. Let me do this. It doesn't matter where you go. It doesn't matter what subject it is, what your concentration is. You always want to know how things, where are values. X represent the values. Okay, let me put this. Oops. X. ภูมิใจ say 5 foot whatever, okay, 5 foot something and 68 kilogram and blah blah blah. Okay, so it's not just one value. X could be a vector value. Okay, but you certainly have X for Pumjai, you have X for Pi2, you have X for this, X for that. That's what you want to know. You want to know how you relate this and that. And it could be linear, but perhaps not. Okay, perhaps not. So, oops. Perhaps not. You want to know the rate of change of something with respect to the other, and you want to know how you accumulate change. Okay? So this is probability statistics. This is function or functional programming. This is differential calculus, integral calculus. Now, this ends up to be the mother of all things, because by using programming, functional programming, you are using y is equal to fx to represent everything. All of knowledge, all of history of humanity's knowledge will be represented by a set of functions. Okay? And that sounds really scary, isn't it? All human knowledge, okay, technological, especially technological, will be represented or can be represented by function. At the very least, you have a lookup function. Okay? So, when was Napoleon Bonaparte born? You go to this. Okay? You go to Google. When was Napoleon defeated? Okay? And the answer is Waterloo, June 22nd, 1815. That's knowledge, right? Well, how did you get that? Because this is your X. So what you were doing just now is saying 1815 06.15 is y. This is your y, right? Y is equal to this, is equal to lookup function of, this is your text. This is your x. This is your x. Okay? And that, sorry.
So basically, the function of this formula is the searching tools, right? So
yeah,
this is x. Oh, okay.
Right. So this lookup function will have so many things. Okay, we have so many things. We have something like it's going to look something like this. For all the document, okay, match Napoleon. If yes, okay, that sort of thing. You see what I mean? It's not a simple thing, right? So there's at the end of the day, the AI, the Google, the chatbot doesn't matter, right? Everything you do from now on, think of yourself as building a function. Okay? So this is material you work with. This is a function you build to do everything. Okay? And these are property of functions. This comes later. Okay? So maybe I should do something like this. D F Y dx. Okay? Y is equal to X. Okay? So these two are realistic. This is not realistic, right? because things that are constant, it's not realistic. You don't grow at rate of 1 centimeter a year. Otherwise, you start from 0 and in 100 years you'll be a meter tall. That doesn't happen. So this is not realistic. This is realistic. This is realistic. But it pertains to what? It pertains to this. Okay? So in summary, think always, whatever the subject of your study is, you study this. You study this. A lot of time you try to start studying this because it's kind of nice. It's kind of simple, right? Okay. But in real life, it can be more complicated. Okay. So that's the idea. So this maybe I should do something like hence. Hence. That's it. That's it. Everything else builds from there. And this thing, the reason I put a lot of emphasis on there is not only because I want you to think mathematically, that's number one, but programmatically, by size program, you will use functional programming. Now, you may have friends in computer science and they will teach you about something else, vector-type paradigm, object-oriented, and so forth. They're very important and they are useful, but for now, hands in hand with this. In fact, Mathematica does functional object-oriented, so does Python. Okay, but the object-oriented part of Python is only just going to wrap function. So fundamentally, we're talking functions. Okay? So focus on this. Look at everything you do from now until you graduate and beyond as building function. Your knowledge is function. Information is function. Prediction is function. Analysis is function. Function everywhere. Okay? So I can say that what's a buy-side graduate? A very good function builder. Okay? Now, obviously, if you just build function and you don't use it, you don't prototype it, people don't get to see it. So you build a function, you prototype it, you demonstrate how it works. Right? How it works. Okay? So anyway, we kind of out of time, but again, next week, okay, we'll come here. I think I would switch up. I might switch up the gear a little bit again because this thing also, this thing and that thing, this is also amenable to a lecture Zoom kind of thing, right? So I'm buying time a little bit by switching. So maybe if next week I this one and the week after, if we haven't got to face to face, if by February 10th get face to face, we'll switch that. So we might switch the order a little bit. Okay. Again, I really didn't design this as a Zoom class, but certainly we can do that. Okay. So right now, definitely your assignment, okay. We're gonna have a first assignment. Okay, the first assignment is uninstructed, meaning that you don't know how what I want from it. All I want for you is to just go to this URL. Now, I want this to happen. Where's the video? Okay. Now, except this last one. This one is a cartoon, right? Except this last one, you will pick one of them. Okay, one of them. Okay. Now, this is a first come first serve sort of thing. So let's say you are Evelyn, right? Evelyn wants to do this one. Okay, you write in the line group that I'm going to do this one. Nobody else gets to pick that one, right? Okay, so no repeat, no repeat, no repeat. Okay, no repeat. And I'm going to give you maybe 1 or 2 minutes or maybe, okay, right? To read. Well, not to read. It's going to take like 5 minutes, not 1 minute. Most of these videos are very short. Okay, watch it. Watch a few times. Okay, each of you write 1 paragraph. I don't want 3 pages. I just want 1 paragraph. Describe synopsis, basically what this video tells you. Not about, by the way, don't ever write anything to me in a homework or in a response with the word about. Okay, about is the most imprecise, information starved statement in English language. Okay, so that's it. This video is about this. What did this video teach you, tell you, and how it links? In other words, because all this, right? Where are we? All these videos came from this. How is this an example? So I already gave you sort of like a hint, right? Why is this an example of unintended bad consequence? Because people could not understand the chemical process, whatever. Okay, so 1 paragraph only. Okay, and again, choose. You can browse through them, right? And then whatever you choose, you write in the you can create a list if you like. Okay, or you know, you can just, well, you guys do that when your friend is voting for a restaurant, right? Okay, so I vote for that restaurant, you vote for that restaurant. In this case, I choose this video, you choose that video. No repeat, no repeat. Okay, any one of these, okay, any one of these, except this one. Also, except this one, because this one is a separate example homework. Okay, so except this one, all these are valid. Okay. Okay, so I'll send you this in the line group, and Peanut will make a course view place to submit. And yeah, this shouldn't take you too long, right? So just have it done by Monday. Yeah, Monday is good. Okay, Monday 8 o'clock, let's say. Okay, Cap. So with that, I think we can close. I will send you this, but you know, this you already. It's not that it doesn't have a lot of text. It's a concept. It's why at the end of the day, doesn't matter what your interest is. This is what you need to know. Okay. So think of something. I don't care what it is. Sustainability, smart cities. What are the X's? What are the Y's and F? And how do we know how it changes, how it accumulates different quantities? Okay. If you know this about anything, you know that thing. Because, like I said, humanity doesn't know by any other way. Analytically, I'm talking about, like, you know, subject of studies. Okay. So notice from here, slide 1 to slide 10, I guess, there's no mention of subject. In fact, I still have no mention of subject, all example. So this is completely universal. I don't care what you study. You have to know, or you have to know what this, which in turn implies. Okay? All right. So let's close with that. And again, I'll see you next week on Zoom. We'll still be on Zoom. Okay? So sorry about that, but keep your spirit up, and the more you questions you have, the better you make this class. Okay, so I really appreciate that. Okay, so I'll see you guys next Thursday the 27th. Okay, see ya.